Hello, this is a Linux desktop, and in this video we're going to be discussing the file system hierarchy standard, and we're also going to briefly touch upon the three-tiered hierarchy of the file system hierarchy standard. In addition to this, we're going to touch upon each directory and briefly explain its purpose. So without further ado, let's take a look at the root file system. This is the root file system, and this is the primary hierarchy location. You'll notice that inside here we have bin, we have boot, we have dev, we have etc, we have home, we have lib, lost plus found, media, mount, op, proc, root, sbin, srv or service, sys, temp, USR, which is often pronounced user but stands for Universal System Resources, and var. First directory we'll be looking at is bin. Bin holds the essential command binaries for the system. Anything you're going to find inside bin should be accessible by all users and should be reserved for what are called essential command binaries. These would be anything that's required to get a system out of single user mode or recover your system. If you're not familiar with the different init run levels in single user mode, that should be discussed in a separate video. But if we take a brief look here, we have your shell, which is going to be bash, the born again shell. We keep looking down, there's the utility to make directories, list the contents of directories, mount file systems. There are several other commands in here, and there are commands that are required to be in here by the standard, but they'll be discussed in a later video. Moving on from bin, we have boot. Inside boot, there'll be the kernel, the init.rd if the system's set up to use an initial RAM disk, and the bootloader. If we take a look here, here's our init RAM file system, here's a kernel, and here's grub, our bootloader, the Grand Universal bootloader. Grub and Lilo, the Linux loader, are the two most popular bootloaders for Linux, but they are by no means the only bootloaders. If we take a look, this is just going to hold the grub configuration files. There's not much to say about it. Moving on from boot, there's dev. Dev holds all the device files for the system. If you're not familiar with what I mean by device files, if you've ever heard the phrase that in Unix everything's a file, this is what they mean. Every piece of hardware on the system is represented as a file. Everything on the system, including processes, are represented as files. So if we take a look at, say, SDA, which is the first primary hard drive of this system, this file is referring to the piece of hardware. So if you need to change the partition scheme, it would be fdisk /dev/SDA, and that's how you would reference the first internal hard drive. Moving on from dev, there's etc. etc hosts all the host-specific configuration files. So everything that is specific to the system is going to be stored inside etc. So if we take a look at the files in here, for example, there's going to be one here called hostname, which just has the hostname of the system. So we'll just open up this file. Taking a little bit longer than expected. Alright, so and the host name is just Steven-Ayers-laptop, and that's the host name of this particular system. These are all configuration files that are specific to the system as a whole, not user specific. If you're familiar with Windows, you might think of this similar to the registry, but they are by no means a one-to-one comparison. Moving on from etc, there's home. Home contains all the files for a specific user. So the user BlueGeek9 owns this directory, and everything in here is for that user. Desktop documents, videos, these all seem pretty expected for a desktop operating system. But if we also take a look at all the hidden files here, we'll notice that it has configuration files for the user. So for example, the GNOME configuration files or the Compiz configuration files for this specific user. This is similar to what you might find in Etsy, but the difference is that these are user specific, whereas Etsy's specific to the entire system. Moving on from user, there's lib or library. This is going to hold all the library files on the system. If you're not familiar with what library files are, you should probably look a little bit at programming, but they're similar to DLLs in Windows world. Dynamic linking libraries are very similar to libraries in Linux. This is just a storage location for them where other binaries may link against them. Moving on from lib, there's lost plus found. Now lost plus found is not part of the standard as a whole, but it is worth mentioning since it is here. If the file system became corrupt and you had to check the file system, any orphaned or lost files that it may have found, it's going to place inside lost plus found. You can find remnants of files that it may have been corrupt, but it is not part of the file system standard. Media holds all your removable media. This is where they're going to end up being mounted. So if we take a look inside, we'll notice that there's a few things mounted on this system. So if we take a look at the system, there's several things mounted here. There's CD-ROM, there's disk 1, disk 2, there's even an iPod mounted here as well. If we take a look inside disk 1, it looks like it's just our Linux system. Moving on from media, there's mount, MNT. Inside mount is very similar to media. The difference between media and mount, though, is mount is a mount point for mounting file systems temporarily. You would mount something here if you needed to recover the system, for example an NFS mount or an FTP mount or even a USB stick you might mount here. It's useful for putting it here quickly, copying what you need to do, then unmounting it. It keeps your system from getting obscure with unnecessary directories.